Hi everyone, this is Sibasis. I am an expert in microservices and cloud fintech optimization. Welcome to FintechFastBytes EP2. On this occasion, I would like to thank AITP for giving me an opportunity to showcase my expertise. So, without further delay, let's start with today's topic, which is cloud performance tuning for financial APIs. The goal of today is to help engineers balance performance, cost, and resilience in high volume fintech systems. So you see today your APIs are running very fast, but until they are not. So then comes the timeouts, the spikes, and the scaling panic that increases the billing. So this is the pattern I have often seen in the enterprise system or the fintech system most often. So today we'll unpack what really causes API slowdowns and why cloud scaling alone is not sufficient, and what are the proven patterns that have solved this problem we are going to find out today. So, coming to what happens when the traffic scales. So, our infrastructure grows, more users come into the system, there are more API calls, and there are more requests per second. Then what happens? The auto scaling gets kicks in. The pods get multiplied, the CPU climbs in, but still we see that the users are still complaining on the slowness. Why? Have you ever thought that? So, this is because the real bottleneck is not our infrastructure but architectural. Most often, we see our APIs are routed through a centralized gateway, then we hit a microservice that sync with the downstream database. So, that is always our pattern of enterprise applications. So, a simple service calls becomes a chain reaction. So, if our DB can't scale, our APIs also won't scale either. So this is the moment when most of the teams start chasing what you call it as a ghost bugs instead of rethinking about the architecture. Now, have we ever thought why our scaling fails? Right. So even though we increase our infrastructure, we still see that users are complaining. One thing we have to keep in mind that the auto scaling is always reactive. Something has happened, the auto scaling has kicked in. It add pods only when the matrices crosses a threshold limit like CPU or memory. But if our service design creates the bottleneck, like for example, let's say a transactional DB or a downstream service scaling pods does not unblock the path. So let's think of we are opening a tool booth in a small bridge or a narrow bridge, right? So we'll have a traffic jam, of course. So that's what it happens really. So in one system, in my experience, which I have reviewed, we scaled the API to 3 times, but the database was not designed to accept concurrent writes. So even though we made our APIs 3x, the database performance got hit and the collision increases. Right. So here the root cause of the problem was not the resource storage, but it was a poor architectural design. Now let's see what are the patterns that works in this case. For example, async processing is the first I want to talk about. In every fintech system, or you take an enterprise system, an async processing, right? What we have to do, what I advise is push all non-critical flows out of the request path. It's as simple as that. Audit logs, loyalty points, fraud scoring, right? These are some of the examples. So you should not block user while we wait for them. Now, let's say a simple example, right? I want to submit a transaction and I want to send an email to someone. Right? We should not hold the user until the email goes to the other users. So that can be a async transaction. Email can be an async. So that helps. So this is a pattern that helps in performance. Second one is smart caching. which is very important, right? All read heavy transaction always hit the database. So we need to examine them, and the read heavy transaction we need to cache it. Cache by user, cache by region, cache by risk level, right? These are some of the example. And always have your expiration rules when you want to take out the cache, you have to reload the cache. So all this is the second parameter. That is, sorry, the second point is smart caching. Third one is the circuit breaker. So when downstream system services slows down or fail, we should fail fast. So we should protect our caller. We should avoid cascading timeouts. So for the failure APIs, we need to analyze if something can be done so that if an API fails, we can return some response which makes sense to the users. And the last one is predictive scaling, right? Instead of reacting to the CPU, we need to be predictive in our business logic. If order volume is forecasted to be spike, as an example, we should scale proactively rather than reactively. So here I want one thing I want to say that these patterns does not don't just help performance, right? But they also lower the costs and increase the reliability as well. Let's talk about a real case study, right? So this we can talk a real case study, and then we can come what mistakes to avoid, right? A real case study could be caching a repeated calls, right, for balance and transaction history. So balance and transaction history, those are historical, so you can easily cache the data. Fraud scoring, fraud, right? If there is a fraud, we score it, so that doesn't need to be live. It can go to an async, as I said. Circuit breakers to external service calls, that is another important one. So all these will result in latency drops, in retry counts drops, and also the infra cost. So this is a live example where we can easily lower down our cost, retry count, and also the infrastructure. So what is the best part have we observed in all these things is we did not do any code rewrite. It is just an architectural fixes. Coming to what mistakes we can avoid, blind scaling is the first. Any performance issue comes, our mind goes to, okay, let us increase the parts, let us increase the CPU. That should not be blind. So we need to always think why we are scaling. Is it needed? Second one is no observability, right? We can't fix what we can't see. So a simple thing is when there is a latency spike, when there are retry counts, and when there are cache hits, all needs to be in a dashboard and alerts so that we know what's happening at the background, and what we see that we fix. Tight coupling, right? Everything is calling everything, so we need to make it loose coupling as much as possible, right? We need boundaries, we need queues, we need event models so that there is no chain reactions, and if one system is down, others don't go down. No fail safes, right? So no retries, no circuit breakers. One API failure becomes five, right? So these are the mistakes we should avoid, right? Now coming to when to tune and what to watch for. So here what I want to say about when should we go for a tuning, right? First one is latency by flow. So let's say examples of notification, logins, or checkouts. So we need to check the latency of these scenarios and we need to tune it. Retry count per service. Is that retry valid? How many times you are retrying? All this information we need to keep in hand so that we can tune that as well. Top 10 endpoints by cost. In my application, what are my top 10 endpoints? What are their costs? How frequent they are used and how we can tune it, right? And the last one I can talk about the error rate during the traffic peaks. That also we should see and we can tune it. Coming to the final takeaways, right? These are the best advices I can give so that you can handle your API performance in a better way and tune it. Wherever possible, use async. As the email example I said, one of them. Cache it what we can, historical data. Data that doesn't change, always try to catch them. Use circuit breakers at your guardrails. If API fails, find out if this API fails, what is my backup plan? That should be written to the users. So instead of that, cascading failures can be avoided. And always scale based on traffic forecast, not based on just CPU. I want to always remember that. So in this short video, we covered what are our challenges. So I'd like to challenges of performance tuning and how we can mitigate it. So share your cloud performance tuning challenges as you go through my video. Tag someone who is building large scale system and who is handling the performance scaling of the application. And always follow me for the next week's video where we are going to cover a very important topic, AI driven microservice optimization, and how LLMs are tuning our infrastructure in a live manner. Until then, thank you. Bye bye.